widget host view, render view host, and another one.
So we could probably have a whole separate talk about content and all of the things that it provides. But I'll just erase this real quick. And since this part of content is useful to us, I'll just say that there is inside of content, there's a web contents, which is the main interface that you use to interact with a page. Actually, I'm going to make this smaller so I leave myself more space. And this is all the cross-platform code to do with loading and displaying a page. And then there is a web contents view. And there are platform-specific implementations of this. Basically, so when I said before that there was just a single one, that's like a white lie. There's a web contents view Aura that is an Aura window that has an embedded widget. And that basically the only thing that ever renders is sad tab. Because normally there's content in front of it. And as soon as that content dies, then you're left with sad tab. So, but this has a child window of a render widget host view. And over here there's a corresponding render view host, which is a render widget host. A render widget host, awesome names.
View lives in content, so it has nothing to do with the real view.
Web contents view lives in content.
So it has nothing to do with that view.
No, this is it depends on which namespace you're in. All of these are inside the content namespace. And then you have your process boundary, and in a renderer you have your render view and your render widget. I think this is a render widget as well. This is on the render process, and this is in the browser process. Host implies you're in the browser process. Not having host implies you're in the render process. And so this guy has and so from, where am I? I used blue, that was unfortunate. But there's an Aura window for this guy, and an Aura window for that guy. And there's actually an embedded views widget here too that contains the sad tab view. But this guy is a child of this one and is sized by this one to always cover sad tab. So when this process crashes, this gets torn down and his view gets destroyed, and all you're left with is sad tab. It's always a little sadness inside just waiting to come out. Yeah, it turns out. Yeah.
In normal case, Chrome browser UI code doesn't ever have to deal with Aura windows directly. Right? It only deals with views and widgets.
Typically, yeah. I mean, it depends on what. There's always exceptions. So, for instance, most often people go through the widget API to do things. You know, the widget API exposes all of the cross-platform stuff, like maximize, close, and various other functionality that your code might want to do. And so people tend to do that. There is an example of an exception is for the Omnibox code, we have a transition when the Omnibox disappears. I think it like fades out or drops or something like that. And so to set up that, there's code that creates the Omnibox pop-up widget. And then that code normally just uses all the normal widget API methods to show it and hide it and stuff like that. But at some point during its construction, it will get that widget. If def use Aura, it goes and gets that native view and then sets like some animation properties on that Aura window, so that subsequently later on, when someone calls views widget hide, that animation properties are set on the underlying Aura window so that it has an animation. That's an example of an exception. That would either be behind an ifdef or an underscore Aura type file. Is where you'd find someone, just like for Windows code, someone might be manipulating something on the HWin. That would have to be an ifdef oswin, or that kind of thing. You can from an Aura window hierarchy, you can always get at the HWin still if for whatever reason you need it. I think it's like get accelerated target.
Widget.
Yeah,
Like
get
accelerated
widget. Yeah, you're right. That will climb all the way back out to the root window host.
So in the view thing, under root view, you have drawn the non-client view. So the browser frame window, it actually lives at that layer, right?
Yeah. So there's like opaque browser frame view and gloss browser frame view and those things. Those are non-client frame view implementations. And the reason there's separate ones for browser is I mentioned that your non-client frame view has to do custom hit testing and also has to deal with offsetting the content, the client area from the non-client area. And so those measurements were different for the browser UI versus standard dialogues. So that's why it has its own set of stuff.
So we are a little bit past the allotted time.
Well,
What was supposed to happen?
Supposed to be 2:20, it says here.
well, okay, I talked too much.
Any final question?
Well, I can tell you briefly one thing is I think there's been a couple of questions that have come up along the way of really good insights, like why do we have these two different systems, especially where one is allowed to be at one level and one is not, and like various other things. What I'm thinking about now, and I'm just calling my exploration V2, is can we have a type that is maybe simpler than both of these, that you could implement both types of things in terms of, and yeah, that's what I'm toying with. Then that way we wouldn't have to have this huge pile of crap to duct tape the two together, and it might be a little bit easier to grok.
Would be a thing that is both a layer and a window
Um,
and a view? No.
I think it would have to be, the presence of a layer would have to be optional, because in views, not every view has a layer. And I don't think we'd want to enforce that, because I think there's some overhead associated with having layers.
Is layers totally into the window manager level?
Layers are, I think layers are an API that are exposed by CC. I think ultimately that's where it makes sense for them to be.
So how much of an interface would there be other than this is a bound rectangle and it can contain other bounded rectangles?
So I made a list somewhere, and I think of the properties of this type of thing. Basically, there's tree properties. There are things like event targeting. What else? Paint processing. A few things like that. And then having a really simple set of observers. Right now, in views, there are many different observer interfaces. For some things, you have to subclass view to observe. Some things, they're like, maybe you implement like widget delegate, or like there's widget observer. It's not clear always why you use one over the other, or when you would have, like, should I have an observer for this, or implement that, or subclass this, or whatever else. I would like there to be like a single observer interface that all of these types share, that have the same capabilities on each. And then I think that a lot of the functionality that we have in Views and Aura and Ash and so on can just be implemented in terms of being observers. One of the neat things about Ash with Aura that I discovered was that huge classes of features could just be implemented as event handlers. And so this really kept the Aura code nice and clean and kept the Ash stuff from polluting it. And so I think that we can go even further with that. And then this type, this core view type, can be very simple. And then there is this set of interfaces for layout management, state change, observation, painting, and so on, that can be used to explain all of the other features that you might implement a UI with. So yeah, I think that could be interesting. And so I was telling Elliot that often what happens is that like every year or so I'll have some thought about how a new UI framework might work, and I'll go off and hack on it for a while and then realize that it's really hard to actually roll it out, and then I'll find a way to kind of migrate some of the existing views or whatever stuff over to that parts of that API, but it never gets fully done. Aura was a little bit more successful than that, just because it was there wasn't any code that had to be migrated because it was all new, and it was deliberately simpler. So that's kind of what I'm thinking about now. Can we come up with a simple way? But maybe there are some ways to, if it turns out to be good and better than what we have right now, we'll have to kind of figure out a transition path for it.
Why is it ever necessary to have more than one layer? I mean, it seems like as long as you define your views or whatever with an appropriate Z order, then you could just draw everything with one layer.
With one, you mean one compositor layer, or?
Yeah. As long as the window manager calls your widgets or your views or whatever to paint in the correct order.
The layer tree provides the, so there's a couple of things there. Layer conflates multiple things. There's kind of the content of the layer, which can be different things, as Antoine's talked about. There's like a content layer, which has a texture. There's a delegated layer, which has like frame data associated with it. There's a whole bunch of other stuff like that. The main thing from Views and Aura's perspective that layer provides is this tree abstraction, which is basically just the ordering. So your UI framework needs to have some notion of ordering in order for it to be able to draw in the right order. And so that's...
But don't you already have that through views? Don't your views already have an order?
Yes, but there's some interleaving. I have to think about that some more.
I think one thing we haven't mentioned, we have two of them, but maybe they don't kick us out. The property bag and the properties.
So Aura windows have implement a property bag. This is again because I didn't want a bunch of Ash stuff added to the Aura window type. But yeah, you can just set random stuff on there that you think is interesting. And then there's other people that might read your properties and do things based on it.
That's like an off-band communication between this world and the Ash universe, right?
Right. It's again kind of like I erased it now, but like the client API, parts of that being like the attorney, like you're using these properties to communicate. One other thing about Ash that was interesting, Ash has many, there's implementing a full window manager. There's features like your desktop background, your regular windows that are determined, marked as always on top, like your task manager and stuff like that. Things like the lock screen, which must always be stacked atop everything else. Here's the root window. There's the system of containers that can kind of be thought of like this. This is a simplistic rendering of it. So for a root window, which is the screen, I might have 4 containers of windows. The background container holds like your wallpaper, which is always below everything else. Your regular top-level windows will go into a default container here, and thus they're all kind of, the order that they're in here is the Z order of them, as the drawer order of them. The always on top windows are always stacked on top of all of these windows, and then your lock screen always appears on top of all of those. And so Ash, there's actually like 10 or 15 containers now for different window types, but this is like a simplistic view of them. There's a layer type and a window type called not drawn, which basically just means this layer is a node in the tree and is here only to enforce drawer ordering. And so these containers are the not drawn type, just so that they don't consume memory for the texture.
So the containers are layers.
Yeah, they're not drawn layers. And then that's just a hint to the compositor as to what order it should draw them. And so we do that in the desktop Aura thing as well for some of the windows.
There was the display thing, right?
Display
manager.
Yeah, that's right. This is, I haven't looked at this stuff so closely, but Chrome OS supports multiple monitors. And so there is a display controller or something like that, and a root window controller. And the mapping in Ash is that there is one root window per screen. And so for my laptop screen here, there is there'll be one root window, and if I've plugged in another monitor, then there'll be a different root window for that, and the display controller will manage all of those. And so in Ash, there are a couple of types. There's the shell, which is like your global state, your singleton. That's everything that gets initialized no matter how many monitors there are. And then there's this thing called the root window controller, which sets up all of the per root window handlers. So some of the event handlers apply to all of the root windows, and some of them apply to specific ones. And so where they're set up depends on that.
All right.
we good?
Thank you very much.
Thank you.